Beneath your feet, thousands of kilometers down, past the crust and the rocky mantle, lies one of the most incredible features of our planet. It's a vast, turbulent ocean, not of water, but of molten metal. This is Earth's outer core, a 2,200-kilometer thick layer of liquid iron and nickel that shapes our world in ways you might not expect. So, what exactly is this molten sea made of? It's primarily liquid iron and nickel, mixed with a dash of lighter elements like sulfur, oxygen, and silicon. The temperatures here are staggering, reaching up to 6,000 degrees Celsius, as hot as the surface of the sun. This intense heat easily melts iron, but the pressure isn't quite high enough to squeeze it back into a solid. That brings up a great question. Why is the outer core liquid when the inner core, which is even hotter, is solid? It's a battle between temperature and pressure. In the inner core, immense pressure wins, forcing the atoms into a solid crystal. But in the outer core, temperature wins, keeping everything in a flowing, liquid state. And this ability to flow is the secret to its power. The outer core is in constant motion, driven by a process called convection. Think of it like a pot of boiling water. Hotter, less dense liquid rises, cools, and then sinks, creating massive, swirling currents. This motion is supercharged by two things: heat escaping from the solid inner core, and lighter elements being released as the inner core slowly freezes and grows. Earth's rotation then twists these rising and falling currents into giant, spiraling columns of liquid metal. This combination of flowing, electrically conductive iron and the planet's spin creates a massive generator. We call it the geodynamo. And what does this dynamo generate? Earth's magnetic field. This magnetic field extends far out into space, creating a protective bubble called the magnetosphere. It acts as our planet's first line of defense, shielding us from harmful solar wind and cosmic radiation. Without the outer core's geodynamo, our atmosphere could be stripped away, leaving Earth a barren world much like Mars. Life as we know it owes its existence to this hidden ocean of metal. How can we be so sure it's liquid? We use earthquakes. When an earthquake happens, it sends seismic waves through the planet. One type, called S waves, cannot travel through liquids. When seismologists track these waves, they see that S waves completely disappear when they reach the outer core, creating a shadow zone on the other side of the planet. This is our clearest evidence that the outer core is a massive liquid layer. The outer core isn't static. It's evolving. It's slowly cooling, causing the inner core to grow by about 1 millimeter every year. As it grows, it releases heat and light elements, which continue to fuel the convection currents that power our magnetic field. In a way, the growing inner core is what keeps the geodynamo running. So the next time you use a compass or see a beautiful aurora, remember the incredible engine deep within our planet. A superheated, swirling ocean of liquid iron, whose constant motion generates the magnetic shield that makes Earth a living world. Thanks for joining this journey to the center of the Earth. If you enjoyed this, don't forget to like and subscribe for more deep dives into our amazing planet.